composition of transformations is doing more than one transformation. I've already gone over all three of them, so really this is just a good way to practice reflections, translations, rotations. There's one specific composition of composition that has its own name. I'm not really sure why this one has a name and none of the other ones do, but a glide reflection, which this one is a glide reflection, is when you do a translation and then a reflection. It's a glide reflection, because the glide is the slide or the translation. I find it best to use a table. You clearly have to make your own table, just a quick sketch of a table, and list the original points. So this is the original. And ABC, so A is at 3, 3. And B is at 4, negative 2. And C is at negative 1, negative 3. So your original triangle. And then you perform the transformations as the way that they're listed in the problem. So this says graph triangle ABC and its image after a translation along the vector negative 2, negative 1. So the first transformation is a translation along the vector negative 2, negative 1. And as you know, that means it's going to go to the left 2 units and down 1 unit. And you just apply that xy to every point. So then A prime is 3 minus 2, so that's 1. And then 3 minus 1, so that's 2. Or you could do it just visually. To go to point A, and then you're going to move left 2 and down 1. And that's the coordinate 1, 2. And that's A prime. And then B prime, same thing. 4 minus 2 is 2. Negative 2 minus 1 is negative 3. So 2, and then down 3, 2, negative 3. And that's over from B, that's over 2 and down 1. And that's B prime. C prime, same thing. Negative 1 minus 2 is negative 3. Negative 3 minus 1 is negative 4. So 1, 2, 3, and then down 4. So there's C prime. And then if you connect the dots, you can see your triangle after the slide. Ooh, that's bad. Or the transformation. So there's one transformation that's been applied. Now we need to do the second one. All right, so to do the second one, it says, and a reflection in the x-axis. So you need your formula for reflection in the x-axis, or your rule. You'll use your formula sheet for that. I've already put it in because this is the first example. It's x negative y. So this means reflection in x, in the x-axis. So your xy becomes x negative y. You're changing the sign of the y value. And we're going to use the prime, the green, the prime points. We don't care anymore about the original because we've already moved it. So we're done with the original points. Once you change it once, now we have a new set of points. So A double prime is the x value stays the same and the y value changes sign. So 1, negative 2. So I go over 1 and down 2. And that's A double prime. B double prime, 2, positive 3, because it was 2, negative 3, so it's 2, positive 3. So 1, 2, and down 3. I went in the wrong direction. Over 2 and up 3. 1, 2, 1, 2, 3. There it is. Up 3. That's B double prime. And then C double prime, the x stays the same, negative 3, and the y changes sign, so positive 4. So I go negative 3, 1, 2, 3, and up 4. 1, 2, 3, 4. And that's C double prime. And then connect the blue dots. So your final image is the double prime. We took the black one and we slid it, and then we flipped it. And you can see this green C and the blue C, they're equal space away from the x-axis because it's been reflected across the x-axis. Same with the blue B and the green B. They're the same distance. I find it very useful to use different colored pens and pencils or whatever to do these so you can follow what you're doing if you're graphing. But that's how you do a composition. You just do one and then do another one in the order that it tells you to do it. So the second example on your page is the third one. So on the top of the back, it's triangle KLM has vertices K, L, and M. Reflect across the y-axis and then reflect it across the x-axis. So first you need to plot your triangle, your original points. 1, 2, 3, 4, and negative 1. And that is point K. 5, negative 2, so over one more, but down to the second one. That's L. And M is at 1, negative 4. So 1, 1, 2, 3, 4. All right, so there is my original. My original triangle. Yeah, yeah, I skipped one. It says to reflect across the y-axis. So the first transformation is a reflection in the y-axis. So if you look at your formula sheet, when you reflect on the y-axis, the y value stays the same, but the x changes sign. So the formula or the rule is xy becomes negative xy. So I'm going to take my original values and I'm going to change the sign of x. And that's going to give me the first change. So k prime is at negative 4, negative 1. L prime is at negative 5, negative 2. And M prime is at negative 1, negative 4. So then I'm going to plot those. It should just be taking this black one and flipping it across the y-axis. I could also do it graphically. M is one space away from the y-axis, so I went one space on the other side, and that's M prime. L is 5 spaces away, so I'm going to go 5 in the other direction. 1, 2, 3, 4, 5. That's L prime. And then K prime is just over 1 and up 1. And then you should verify that your coordinates match your table coordinates. But using a table means you could actually do these transformations without having the graph. Like if you just wanted to, you just needed the coordinates, you weren't actually asked to graph anything, you could just do it in the table. All right, so then the second one, it says, and then reflect it across the x-axis. Because the order of these matters. If I reflected it across the x-axis and then I reflected it across the y-axis, it would not look the same. It would look different. So you have to do the order it tells you to do it. So to reflect it in the x-axis, the x stays the same and the y changes sign. So x, negative y. And this can be a little bit confusing sometimes. Once you're done with once you're finished with this rule, it might help you to cross it off. In this case, it's not that big of a deal, but I guess maybe in the next one. I'll go back over that in a minute, in the next problem. And this one is not really confusing. But remember, we're finished with the original points because we've already done that. Now we're looking at the green points, the second column. So x is -4, and change the sign of y, so it comes +1. That's k double prime. L double prime, change the sign, leave x, -5, change the sign of y. Becomes +2. And M double prime, leave x, change the sign of y. So -1, 4. And then I can plot these points. I'm flipping it across the x-axis, so L is L double prime. I messed up those letters, didn't I? That's a K. That's a K double. This one's K. So this is K double prime. And then L double prime would be right here. And M would be here. At -1, 4, -5, 2, and -4, 1. So just verify your points match what you graphed. That's M double prime. So I took the green triangle and then flipped it up to the top. So there's also something special about this order of transformations. When you do reflect across the y and then reflect across the x, it actually ends up being the same thing as if you rotated 180 degrees. So that is the same as a 180 degree rotation. So if I picked point L, for example, and I rotate it 180 degrees, I'm going to go counterclockwise or to the left, and it's going to move 2 quadrants for a 180 degree rotation. And it does. So if I took that black one and I turned it to the left, I would end up with the blue one. So that is one composition of transformations that's the same thing as a rotation. But not if you do x first and then y. That's not the same thing. All right, so then the next example is the same. I didn't change this one. We have triangle PQR. So the original, 5, -2. 1, 2, 3, 4, 5, down 2 is P. Q is at 1 and then down 4. And R is left 3 and up 3. So there's the original triangle. This says that I should reflect triangle PQR across the line y = x. All right, so to reflect across, reflect across the line y = x, xy becomes yx. That rule is that they trade places. But before I do that, I want my line of reflection on my graph. It's good to put that line on there so you can see as a visual check to if it looks like you did it correctly. And it's a real quick, easy check. You just draw the diagonal line and then do the points. All right, so P prime, if I swap x and y, should be -2 and 5. So I go -2 and up 5. And that is P prime. Q prime would be -4 and 1. So 1, 2, 3, 4, 1. That is Q prime. r prime, 3, negative 3. X and y trade places. To reflect across the line, y equals x. 1, 2, 3, 1, 2, 3. And that is r prime. So if I connect the dots for my triangle, I can see that it does look like it's a reflection across the line. So point Q and Q prime look to be the same distance to the orange line. P prime and P look to be the same distance. And R and R prime are the same distance. And then it says after that, and then rotate it 90 degrees about the origin. So I'm going to do a 90-degree rotation. I'm going to rotate it 90 degrees. The formula for a 90-degree rotation is negative yx. All right, so this is where I feel like it could be confusing because we just wrote the rule of yx, the green rule that we wrote right here. We just wrote this one. And now it's negative yx. So you do tend to want to just be like, oh, well, if I just make that a negative, if I just change the sign of y, it's already yx. No, that's not the case. You can't just do that. This is assuming you have xy's. So we had the original points, and then we applied this transformation. Once we finish that transformation, we're done with that. These are now xy coordinates again. They're not yx, they're xy's. And so from the new xy's, you do negative yx. So I need to change the sign of y, and then they trade places. This y is 5. So it becomes negative 5 and moves to the x spot. So negative 5, 2. So that's p double prime. 1 is the y value. Change signs. It becomes negative 1. And then it takes x's spot. So negative 1, negative 4 is q double prime. So r double prime, we're going to take the negative 3, change sign so it's positive 3, and then move it to the x's spot. So that's 3, 3. So be careful about that. Once you make a new set of coordinates, forget about everything you did before that. Now that is xy. It resets. Once you do a whole set of coordinates, like resetting, now it's xy again. All right, so negative 5, 2. 1, 2, 3, 4, 5, 1, 2. It's right here. That is p double prime. Negative 1, negative 4. Did I mess that up? Negative 5, negative 2. I missed that, didn't I? Negative 5, negative 2. In the table, I messed it up. Sorry about that. Because the x was negative 2. The x didn't change signs. Negative 5, negative 2. And that is p double prime. Negative 1, negative 4. 1, 2, 3, 4. That is q double prime. And 3, 3. That is r double prime. All right, so we should have rotated 90 degrees. Let's see, it's a 90-degree rotation from the green one. So if we started here, we rotate counterclockwise. It should move 1 quadrant. It did. So that's a quick check to make sure you did it somewhat right. Okay. So I have one more example. I did change this one. So go ahead on the one that I printed off for you. I changed all those points, so just cross them off and make them these points. I feel like it makes a clearer graph if you use the ones I changed it to. So change your ABCs to those points. A is at 4, -1. B is at 5, -2. C is at 1, -4. So 1, 2, 3, 4, down 1 is A. And then 5, -2. So that's one more, and then down one more. That's B. And then 1, -4 is C. I feel like this triangle makes for a better example. So we have A, B, C. And it says to do a rotation of 270 degrees. So a 270-degree rotation, you need the rule for that. So if you look at your sheet, it's y negative x. So you write the rule. And then apply the rule to your points. So I need to change the sign of x. Always change the sign before you swap them. Change the sign of x, and then they switch places. So x is 4, so -4, and I'm going to move it to the y spot. So that means -1 becomes x. And that's A prime. B prime, I need to find the x. It's 5. Change the sign of x, so it's -5, and then move it. So then -2 takes x's spot. And the same with C. To get to C prime, the x value is -1, change the sign. The x value is 1, change the sign, it's -1, and then move it. So -1 is the new y, -4 is the new x. All right, so then plot those points. We have -1, -4, and that's A prime. -2 and 5, down one more and over one more, that's B prime. -4, -1, 1, 2, 3, 4, down 1, is C prime. So that's our new triangle. We have rotated it 270 degrees. Again, it's a good idea to check your rotations. Pick a point. I'm going to pick point B. To rotate to the new point B, I moved 3 quadrants in a counterclockwise motion. 3. 270 degrees, that does require 3 quadrants, so that looks right. Then I'm finished with that rule, so I'm going to cross it off so it does not confuse me. If it helps to cross off the originals, cross those off because you're not going to use them again. Now you only have one set of points to look at. So it says, then translate it using the mapping given there. So I'm going to write that as a vector. It's easier to use it in a table as a vector. -1, +2. So the vector -1, 2. So I'm going to subtract 1 from all of the x's, and I'm going to add 2 to all of the y's. And that should make each point move to the left 1 space and up 2 spaces. So for A double prime, -1 minus 1 is -2. -4 plus 2 is -2. So if I go to A prime, and I go left 1 and up 2, that gets me to -2, -2. That's exactly where it should be. Both methods check out. Moving it graphically and moving it according to what I calculated, that puts it in the right spot. It's like a way to check yourself. B double prime. -2 minus 1 is -3. -5 plus 2 is also -3. So I go 1, 2, 3, 1, 2, 3. And yes, that relationship from A prime to B prime is the same relationship that A double prime to B double prime has the same relationship as A prime to B prime, and the same relationship as A to B. So they're all on the diagonal, one away from each other. Just checking as you're going. And then C double prime, -4 minus 1 is -5. -1 plus 2 is 1. So -5 and 1. And that's C double prime. So yeah, it moved left 1 and up 2, which is what I wanted to happen. Connect those dots. And that's it.